Good day to all of you. In today's session, the content is regarding intermediate, which will be fetching for your international entrance or competitive exams you are aspiring for, and India level JEE Advanced, JEE Mains. This will be helpful for your IIT and NIT examination, that is the technical domain. Medical entrance examination called a NEET, which is conducted across India. There also you can find the content. In addition, Telangana and Andhra Pradesh MCET examination will be there, which will be helpful for the engineering entrance, BTech entrance examination. Again, it is the technical domain. In addition to all these, there is another section, we can say government examination. Most of the people are aspiring towards the government career, where they have to go for the preparation with the different kind of content. General studies is the common question paper which is available, which is conducted for each and every aspirants. There you can find the general science. In the general science, the content what we are discussing is very much fetching. Let's enter into our today's session. Explain the optical isomerism of the following compounds as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. So here, optical isomerism is denoted with two naming. One is called R, second is called S. R denotes a rectus, S denotes a sinister. If you are moving from higher priority to lower priority in a clockwise dimension, it is called R configuration. Anti-clockwise rotation called counterclockwise, which is called S, right? So this is the way RS nomenclature, which is also called as absolute configuration. In order to assign the absolute configuration, the compulsory condition is the carbon must be chiral. Chiral carbon is said to be any carbonatum around which four different functional groups are accompanied. Then we can say that is the chiral or optically active carbonatum. Here, two compounds are provided. In the two compounds, what will be the absolute configuration we have to assign? If you observe this, this is the carbon around bromo, chloro, fluoro, hydrogen are present. Same will be there, but there is a kind of change in their position. So that we can say both the carbons are mentioned with the star mark, which are called chiral centers, chiral carbonatoms, with the four different functional groups, right? So this is the way chirality is mentioned. Let's go for their RS nomenclature. In order to mention the RS nomenclature, first of all, we have to give numbering. How to give numbering? 1, 2, 3, 4, we are not supposed to write like that, but we have to follow some rules and regulations. They are provided by Kahn-Ingold Prologue. According to Kahn-Ingold Prologue rule number 1, we have to go for higher the atomic number, higher will be the priority. Obviously, bromo will be accorded with higher atomic number, next level chloro, next level fluoro, next level hydrogen. This is the way 1, 2, 3, 4 order will be given. And we are moving in this direction, going from 1, 2, 3, 4 dimension, so that this is the way we can say clockwise rotation. Clockwise rotation will be assigned with R configuration, and always fourth priority group must be away from the viewer. This is the suitable arrangement only. And in the second one, chloro is replaced with the bromo. Both are interchanged. Whenever you're going to start numbering from bromo, 1, 2, 3, 4. This is the case. There is an ambiguity in giving, in moving, so that only the thing we have to do 1 to 2, 2 to 3. This is the way you can follow, so that whenever you are moving from 1 to 2, 2 to 3 like this, so it looks like a counterclockwise, nothing but anti-clockwise rotation. Anti-clockwise rotation designated as S configuration, right? So this is about RS configuration. Now we have to assign IUPAC name for the compounds, right? Being it is a one carbon, so that parent chain will be methane. So here different functional groups can be written as per the alphabetical order. Let me put R, bromo, chloro, fluoro, methane. R, bromo, chloro, fluoro, methane is the IUPAC name of this compound included with its absolute configuration. And this is the compound where you can find S. Remaining are same. So whatever the position but alphabetical order to be followed, that's the reason why S, bromo, chloro, fluoro, methane can be mentioned for compound number 2. This is the way configuration and subsequently IUPAC name will be assigned in this optical isomerism. So hope the question is very clear and each and every point is mentioned with the detailed explanation. So for question number 1, absolute configuration for both the compounds and their detailed IUPAC name is mentioned like this. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. Which statement about the noble gases is correct? They are asking the question regarding P block in specific noble gases. Noble gases are diatomic molecules, never found in diatomic form, right? All the noble gases are monoatomic in nature. So this is the wrong one. Noble gases are reactive gases. Noble gases always regarded as inert gases. We can't say reactive gases. Noble gases have full outer electronic shell. This is the correct one. Completely filled outer electronic shell is their strength for noble gases. Noble gases are found on the left hand side of the periodic table. If you observe the periodic table, they are at the most right hand side. That is the completely last row in the right hand side, not the left hand side. Left hand side we can start with the ace block elements, right? So this is also wrong. Among all the given options, the correct one is completely filled. Let's check how can we see completely filled. Here, noble gases are pertaining either 8th or 18th group. We can pronounce as here 18th group is mentioned. And helium abbreviated as He, neon Ne, argon Ar, krypton Kr, xenon Xe, radon Rn. This is the way noble gases are given. Let me repeat again. Helium, neon, argon, krypton, xenon, radon are the elements which are resided in the noble gases. And helium with atomic number 2, so that 1s2 is the outer shell configuration. This is completely filled. Neon, atomic number is 10, so that let me mention 1s2, 2s2, 2p6. Octet means 8 electrons in the outer shell. 8 electrons is the maximum limit, so that completely filled we can say. Argon with atomic number 18, outermost shell is 3s2, 3p6. Again it is octet, completely filled. Krypton with atomic number 36, outer shell configuration is 3d10, 4s2, 4p6. This is 18 electron rule it will follow. Xenon 54 with a 4d10, 5s2, 5p6. Again 18 electrons will be pertained. Radon, Rn, it is a radioactive element, atomic number 86, 4f14, 5d10, 6s2, 6p6. This is the way outer shell configuration. If you observe all the elements where you can find octet in their outermost shell, completely filled configuration is observed. So that second one, C option is the correct answer for question number 2. Move on to question number 3. Question number 3 collected from JEE Advanced 2019 question paper 1 question it is. Choose the reaction from the following options with which standard enthalpy of the reaction is equal to standard enthalpy of formation. Standard enthalpy of the reaction is equal to standard enthalpy of formation, right? Here, निम्न विलुप्तों में से वो अभिक्रियाएं जिसकी और जिनकी मानक अभिक्रिया enthalpy. Standard enthalpy is called मानक अभिक्रिया enthalpy of the reaction. अपने मानक विरचन enthalpy, standard enthalpy of formation के समान हो उसे चुनिए. Standard enthalpy of formation and standard enthalpy of reaction, both must be equal. Those reactions must be chosen, right? So first of all, we have to know what is meant by standard enthalpy of formation. The standard enthalpy of formation of the compound is the change in standard enthalpy when 1 mole of the compound is formed starting from requisite amount of elements in their stable state of aggregation, right? 1 mole of compound formation is prominent over there. 1 mole of compound formed in the option 1, 2 moles formed so that we can discard option number 2. In the third one, you can find 1 mole of product formation. In the fourth one also 1 mole of product formation is possible. Standard enthalpy of the formation is nothing but from the requisite amount of starting elements, a 1 mole of product formation is required, that is called standard enthalpy, which is observed in option 1, option 3, option 4. For question number 3, option 1, option 3, option 4 are correct answers. Same sentence is given in Hindi as well. संभावन की मानक एंथैल्पी, पदार्थ या यौगिक की मानक संभावना उष्ण मानक उष्ण में परिवर्तन जब 1 मोल यौगिक अपने प्रामाणिक तत्वों की आवश्यक मात्रा से इसकी स्थिति संगुणित अवस्था में बनता है. So, संभावना की मानक enthalpy is nothing but standard enthalpy of formation when it is possible. So, पदार्थ या यौगिक की मानक संभावन उष्ण मानक उष्ण में परिवर्तन जब 1 मोल यौगिक अपने प्रारंभिक तत्वों की आवश्यक मात्रा में उसकी स्थिति संगुणित अवस्था में बनता है. So 1 mole yaugic is nothing but 1 mole of the compound formed is required, right? So that is the important condition which is available in option 1, option 3, option 4, right? Move on to question number 4. Question number 4 is also collected from JEE Advanced 2019 question paper, paper 1. Consider the kinetic data given in the following table for the reaction A plus B plus C gives rise to the product. This is the data given. This is the question given from the chemical kinetics. This is the physical chemistry domain. Here they are doing the experiments 1, 2, 3, 4. 4 different experiments were done. So starting materials A concentration, B concentration, C concentration were taken. And with respect to concentrations, what will be the rate of the reaction is also mentioned. The data given that A concentration 0.2, B concentration 0.1, C concentration 0.1 gives the rate of the reaction 6 into 10 to the power negative 5. So if the concentration says 0.2, 0.2, 0.1, then again rate of the reaction remains the same. When the concentrations are 0.2, 0.1, 0.2, the rate of the reaction got doubled. It became 1.2 into 10 to the power negative 4. 0.3, 0.1, 0.1. If this is the concentration of ABC, 9.0 into 10 to the power negative 5. So the reaction got increased. Rate of the reaction got increased. This is the data provided, and the rate of the reaction for A is equal to 0.15 mole decimeter inverse cube, B concentration 0.25 mole decimeter inverse cube, C concentration is equal to 0.15 mole decimeter inverse cube, is found to be Y into 10 to the power negative 5 mole decimeter inverse cube second inverse. The value of Y is, so these are the concentrations provided. At these concentrations, what will be the rate of the reaction? So what will be the rate of the reaction? In that 10 to the power negative 5 already given. Y to be identified. Okay. So given concentrations, rate of the reaction is given within the data. For these concentrations, what will be the rate of the reaction they are asking? Okay. So known to unknown. We are forwarding from known to unknown. So this is the chemical kinetic question purely. So let's see the same question in the Hindi version as well. निम्न सारणी में A plus B plus C gives rise to उत्पाद product की अभिक्रिया के बलगति आंकड़ों पर गौर कीजिए. ओके, सो A प्लस B प्लस C उत्पाद की अभिक्रिया में बालगति की, दैट मीन्स काइनेटिक्स. सो आंकड़ों पर गौर कीजिए. सो प्रयोग संख्या 1 2 3 4, concentrations of A, B, C, just now we gone through this. Abhikriya Gati, so rate of the reaction also provided. जब A concentration 0.5 mole decimeter inverse cube, B concentration 0.25 mole decimeter inverse cube, और C concentration 0.15 mole decimeter inverse cube है, तब अभिक्रिया गति y into 10 to the power -5 मोल डेसीमीटर इनवर्स क्यूब सेकेंड इनवर्स पाई गई. y का मान है, y वैल्यू टू बी आइडेंटिफाइड. इट इज कैलकुलेटेड एज 6.75. y is calculated as 6.75. We have to get how to calculate this. How can we get this answer? In order to do that, we are going for the detailed calculation part. Rate of the reaction is equal to, here three different reactants we have. What are they? A, B and C. So in order to get the rate of the reaction is equal to K into A to the power small a, B to the power small b, C to the power small c. These concentrations are required. If you observe the experiment number 1 and 2, 1 and 2 experiments, if observed, one concentration remains constant, say B concentration got doubled, C concentration remains a constant. Only the thing we are doing is A is not changed, C is not changed, B is doubled. Though B value is doubled, but rate of the reaction is not changed. That means B concentration will not alter rate of the reaction. With respect to experiment 1, experiment 2, concentration of B is 0. B concentration is taken as, B rate of the reaction is taken as 0. Okay. Then experiment 1 and 3. Experiment 1 and 3. If you observe one experiment, 0.2 is the concentration of A. 0.2 is the concentration of A. So concentration of A is not changed. B is also 0.1, 0.1. C is 0.1 doubled to 0.2. Whenever 0.1 converted into 0.2, 6.0 converted into 1.2. Again here doubled. So that what you can see. So whenever concentration of C doubled, rate of the reaction also doubled. That means what? C is equal to first order. C. Reactant C follows first order. By the experiment number 1 and 4, if you observe 1 and 4. So 1 and 4, let's see. A is 0.2, here is 0.3. A value got increased. B value 0.1 remains 0.1 only. C value remains 0.1 and 0.1 only. But this 6.0 into 10 to the power -5 converted into 9.0 into 10 to the power -5. If you are changing the value of A concentration, rate of the reaction also changed accordingly. Right? That indicates A also follows first order. B follows zero order, C follows first order, A follows first order. So if you put all these exponentials over there, R is equal to rate of the reaction is equal to K into A to the power 1, B to the power 0, C to the power 1. These powers you calculated, right? So this is nothing but power, nothing but order of the reaction, right? From the experiment number 1, number 1, A concentration is given as 0.2, B concentration is given as 0.1, and Abhikriya Gati, that means rate of the reaction, is given as 0.6.0 into 10 to the power -5. So 6.6 into 10 to the power -5 is equal to K into 0.2 into 0.1. Let's put in the experiment number 1 values. Okay, whenever we are having all these, K is unknown, all the numerals are known. So that K is calculated as 3 into 10 to the power -3. K is calculated as 3 into 10 to the power -3. This is for experiment number 1. A in the data, In the data they mentioned A concentration is 0.15, B concentration 0.25, C concentration 0.15, and this to be identified. So that data we are repeating again: A concentration, B concentration, C concentration. So, and already we got a relation between all the reactants. Rate of the reaction is equal to K into A to the power 1, B to the power 0, C to the power 1. K value just now we calculated 3 into 10 to the power negative 3. Let's put the value. K is a proportionality constant which is calculated. A value is known 0.15. B is known 0.25. And uh, B to the power 0, that's the reason why it is taken as 1 only. C to the power 1, so that let's put 0.15, right? So K is a calculated value, A is known to you, B is known to you, C is known to you. If you substitute all the values, it is calculated as 3 into 0.25 into 10 to the power negative 3. 0.15, 0.15 will become 0.025, right? So from this, if you multiply this one, you will get 6.75. 6.75 into 10 to the power negative 5. So negative 3 can be converted into negative 5 by adjusting the decimal point. So whenever you got this 6.75 into 10 to the power negative 5, so here 10 to the power negative 5 already given within the problem. 10 to the power negative 5 is given. Only the unknown is y. Y is calculated as 6.75. So 6.75 is the required answer over there. This is somewhat lengthy and logical question given from the chemical kinetics. So we should have the idea about how the concentration changes, what is the change in the rate of the reaction that we have to observe. So if concentration remains unchanged, zero order. Concentration doubled, rate of the reaction doubled, so that we can go accordingly. This is the way problem can be solved, and everything is clearly mentioned over there. Hope it is very clear. Move on to question number 5. Question number 5 is collected from what we can say. It is the part of inorganic chemistry. Consider the following. The order of first ionization enthalpy of first three elements, the third period is magnesium, aluminium, sodium. They are saying that magnesium first ionization enthalpy value is larger, next is aluminium, next is sodium. Actually, as per the periodic trends, what is the condition? Left to right, if you are forwarding, so gradually ionization enthalpy values increases. As per that, sodium must have least value. Next element will be magnesium. Highest should be given for aluminium. But exceptionally, we have magnesium higher value, next level aluminium, next level sodium. But it is correct only. The element with electronegativity 3.5 is chlorine. 3.5 electronegativity value is given for oxygen, right? The order of the sizes of ions: magnesium, magnesium plus 2, sodium plus 1, fluoride F minus 1, oxygen O minus 2. So if this is the case, always the thing we need to remember is negative ions are larger, positive ions are smaller. If they are isoelectronic in nature, always put negative ions in front, positive ions least. Greater the negative charge, larger the size. Obviously, O minus 2 is larger, next followed F minus. Na plus is smaller, and magnesium plus 2 is the smallest. The IUPAC name of the element with atomic number 106 is borium. 106 element borium or not, we have to check it out. So that this is about the data we got. From this, we need to identify which are correct. For that purpose, here the same question given in Telugu. క్రింది వాటిని పరిగణించండి. మూడవ పీరియడ్ లోని మొదటి మూడు మూలకాల ప్రథమ అయోనైజేషన్ ఎంథాల్పీ క్రమము మెగ్నీషియము గ్రేటర్ దాన్ అల్యూమినియం గ్రేటర్ దాన్ సోడియం. రుణ విద్యుదాత్మకత 3.5 గల మూలకము క్లోరిన్. మెగ్నీషియం ప్లస్ 2, సోడియం ప్లస్ F minus O minus 2 అయాన్ల సైజుల క్రమము మెగ్నీషియం ప్లస్ 2 smaller than sodium plus smaller than Fluoride F minus smaller than O minus 2. Paramana Sankhya నూట ఆరు గల మూలకం అయ్యుపాట్ నామం బోరియం. వీటిలో సరైన వాటిని మనం గుర్తించాలి, రైట్? సో అమాంగ్ ఆల్ 1 and 3 only correct. 1 and 3 means, so this first ionization enthalpy and size of the ions 1 and 3 are correct only. Let's see how can we explain this one. In order to explain, magnesium having atomic number of 12 and electronic configuration 1s2, 2s2, 2p6, 3s2. If you observe the valency shell completely filled, this is the exceptional condition we need to observe. But aluminium is having 3s2, 3p1 outer shell configuration. That means 1 electron free. So this is completely filled. This is 1 electron. And in case of what is the sodium? If you observe the sodium 1s2, 2s2, 2p6, 3s1, 1 electron is free. They're asking for first ionization enthalpy. First ionization enthalpy means what? Removal of 1 electron. Obviously, sodium will remove 1 electron very fastly in order to attain nearby neon electronic configuration. So that it is very fast, so that leads the ionization enthalpy. And next level element is aluminium, because whenever this electron removed, completely filled will be there. So that again it tends to remove the electron. In case of magnesium, being it is the completely filled and itself it is the stable, so that removal of electron is very difficult. So it contains a higher ionization enthalpy. That's the reason why exceptionally the order will be magnesium and followed by aluminium and followed by sodium. This is correct only. Element with electronegativity 3.5 is chlorine. They are saying, let's observe. Chlorine is 3.16 only, but oxygen is 3.5. So this is the wrong one they mentioned. Wrong one they mentioned. So, and the next is about order of the sizes. Just now we gone through. If the cation is there, the size is very small. If the anion is there, the size is very large. So that this will be the right order only. 3 is the correct option. But IUPAC name of the element 106 is borium is the wrong one, because let me show. Okay. So 106 atomic number element is a seaborgium. Seaborgium is the right answer. Borium atomic number is 107. Okay. So this is the way we can answer. This is purely, this data purely on periodic table. If we have the complete idea about the periodic table, so that we can answer about this question. Electronegativity is repeatedly given for the competitive examinations. Ionic radius, atomic radius also plays a vital role. Enthalpy of ionization is also important. Electron affinity values are important. And all what we say, periodic table elements also most important. So this is purely based on periodic table, periodic trends, right? Move on to question number 6. This is the last question of the session, where we have some list of the elements in the one side and another list of elements in the second side, so that we have to map a correct one. What molecule or ion are provided and what will be their shape, we need to identify. This is purely based on inorganic chemistry, especially chemical bonding related question. Here SnCl2 is called a tin chloride, stannous chloride, and NH3 is ammonia. Next I3 minus is called I3 minus iodine anion, right? So SO3 is called sulfur trioxide. If these are the molecules and ion included, so that what will be the shape? Trigonal, planar, linear, angular, trigonal, pyramidal. Same will be given in Telugu as well, where we have SnCl2, ammonia, I3 minus, SO3. And the expected options are Trikona Samatalam, Rekhiyam, Koniyam, Trikona Suchiyakaram. Means Trikona Suchiyakaram means trigonal pyramidal, right? So let's see one by one. So the expected answer is option number, sorry. The expected answer is option number 4, where A can be mapped with 3, B with 4, C with 2, D with 1. So let's see the detailed explanation. Tin chloride, if you observe, it is angular in nature. In order to give the angular nature, sp2 hybridization will be there. sp2 hybridization, if follows, one of the lone pair resided on this tin, right? So tin 2 chloride SnCl2. So tin dichloride, it is mentioned sp2 hybridization, so that an angularity saying, right? Next, if we go with ammonia molecule, nitrogen is accorded with the sp3 hybridization, and one of the lone pair is located on the nitrogen, so that the shape of the molecule is pyramidal in shape. And next is about I3 minus. I3 minus is a linear molecule. All iodines are laying on the same line, so that linear in nature. And all iodines are sp3 dehybridized. Sorry, central iodine is uh, central iodine is sorry central iodine is sp3 dehybridized atom will be there, and all are laying in the same line. And next is about SO3 molecule. If you observe SO3 molecule, sulfur is at sp2 sp2 hybridization. One s orbital and two p orbitals got mixed up, and it is trigonal planar in shape. Trigonal planar because all orbitals, all three orbitals are participating in bonding, so that trigonal planar is the shape as well as geometry for the molecule. So all these are clearly mentioned over there. Let's see. SnCl2 can be angular in nature. Just now we saw with the one lone pair of electron. NH3 is a trigonal pyramidal in nature. I3 minus is a linear molecule. SO3 is a trigonal planar. In Telugu, SnCl2 అణువు ఏ ఆకారంలో ఉంటుంది? కోణీయ ఆకారంలో ఉంటుంది. అమ్మోనియా త్రికోణ సూచ్యాకారంలో ఉంటుంది. I3 మైనస్ రేఖీయ ఆకారాన్ని కలిగి ఉంటుంది. SO3 త్రికోణ సమతల ఆకారాన్ని కలిగి ఉంటుంది. So by this we entirely completed the session, and we covered with the different dimensions of chemistry, where various parts included with the organic chemistry, physical chemistry, IUPAC nomenclature, inorganic chemistry, periodic properties, periodic trends. So many kind of sessions got covered over there, and definitely I will assure for increasing your enthusiasm towards the chemistry. Hence, I'm sincerely requesting you to kindly like the channel, comment which part is really important towards your preparation, share with the aspirants who are serious about the examination, subscribe the channel to achieve more such kind of updates in the near future. Thank you very much for your patient listening. Thank you one and all.